So, hello everyone, good evening. So, today we are going to have our editorial discussion topic on Chandrayaan 3. So, Chandrayaan mission we have already discussed about it, and yesterday the Indian Space Research Organization has demonstrated the soft landing capacity of the lander module on the surface of the moon, right? So, related to that we are going to discuss about many recent developments, right? Not only we are going to understand about the recent developments related to Chandrayaan mission, but we are also going to understand some basic scientific principles. We are going to understand about basic scientific concepts related to any space exploration mission. And after that, we are going to talk about how this particular event of doing a soft landing on the surface of the moon is a significant achievement for Indian Space Research Organization and for India in demonstrating its scientific progress or its scientific prowess, to the globe at large, to the world at large. So, since the entire world is, let's say, looking forward for doing a space exploration, at this point of time, ISRO has showcased that it has the capacity to lead different nations in spacefaring activities. So earlier, like in our previous lectures, we have discussed about some important things, right, related to the Chandrayaan mission. So we are going to work upon them today. So I will quickly touch upon the all those things that we have discussed earlier, so that you have a basic, let's say, understanding about the space missions of ISRO and space missions of any other country, and after that we are going to build upon that, right? So the topic that we are going to discuss today is, largely is Chandrayaan 3 mission. Okay, we are going to discuss about Chandrayaan 3 mission. So objective of today's lecture will be little extra as compared to previous what we have discussed in Chandrayaan mission, right? So when we talk about Chandrayaan mission, right? So when we talk about Chandrayaan mission, so when we discuss about Chandrayaan mission, so Chandrayaan is the lunar, right? It's a lunar mission of India, right? So lunar space mission of India, lunar space mission of India. Now, to understand about lunar space mission, first of all, we will understand about some of the basic scientific concepts, and then we are going to discuss about further related to this thing. We are going to talk about how it is bringing India to the greater, to the next level of space exploration, right? So the topic is, let's discuss about one of the law which is known as Kepler's law. Okay, this is known as Kepler's law of planetary motion. Okay, Kepler's law of planetary motion. Many of you may be having doubt, how these let's say artificial satellites that we are sending, right, or spacecrafts that we are sending, how they are able to glide through in the space, how they move from one planet to other, right? So for that, this Kepler's law of planetary motion will help you in understanding those concepts. Kepler has given 3 laws. Okay, he has given 3 laws. So these 3 laws talks about the, let's say, laws of planetary motion. So first law that we are going to understand is, this is known as Kepler's first law. Kepler's first law. So let's discuss what is Kepler's first law. Kepler says that every planet that revolves around the sun, right? So they revolve around the sun in a predetermined orbit, right? They revolve around the sun in predetermined orbit that is based on various, let's say, things. So these orbits, right? These orbits take a certain form, and this form is known as, these orbits are known as elliptical orbit. Okay, this is known as elliptical orbit. So why it is said to be elliptical? Because of the shape. We know, let's say, we know this is a geometrical thing. So it is a circle. circle has one center only, right? Circle has one center. But the planets that orbit around the sun, they orbit in elliptical orbits, right? So this shape is elliptical orbit. It has two focus. This is focus 1. This is focus 2. Okay, it has two focus. And the line, if we draw from focus from one side to the other side, this line is known as major axis. This white line that we have drawn, it is known as major axis. Okay, this line is known as major axis. Then if we draw another line from here to here, let's say this is the line, this is known as minor axis. What? It is known as minor axis. Okay, it is known as minor axis. So this ellipse has two focus. One of the focus is known as f1, other is f2. Let's consider at f1 we have the location of sun. Let's say our sun is located in f2. Okay, it is located in f2. And let's say we have a planet which is planet Earth, right? This is planet Earth. And if this planet is revolving around the sun, so it revolves along this particular orbit. This orbit is known as elliptical orbit. Okay, and if I draw some parameters, for example, from here to here, the distance, let's say I am saying this is distance A, this is distance again A, right? So major axis has a length of 2A. Okay, major axis has a length of 2A. And if I talk about this B, this is minor axis. This minor axis has a length of, it has a length of 2B. Okay, it has a length of 2B. So the first law of Kepler, it says all planets revolve around their star, around their sun in an elliptical orbit. Okay, it says they revolve around their planet in an elliptical orbit. This is the first law of Kepler. Okay, this is Kepler's first law. Apart from this, we are going to discuss about Kepler's second law. Is it understood, Kepler's first law? Kepler's first law talks about the direction, means like, the orbit, the path that let's say, planet follows around its star. Then second one is Kepler's second law. Write down Kepler's second law. Kepler's second law. So to understand Kepler's second law, we again need this diagram. Okay, we again need this diagram. So draw this diagram along with me. This is again an ellipse having two focus, right? They are together known as foci. In plural, it is known as foci. Let's consider sun is located at one of the foci here. Focus is the central point. Let's say this is a circle. Circle has something symmetrical around this center one. If you go to any direction from center, you will be having equal distance, radius, right? So this is known as center. And if I talk about this ellipse, right? So it has something around which things are similar. So they have two focus. It is known as foci 1, foci 2, or focus 1, focus 2. Together it is known as foci. So there are equations, right? I mean, like, it's a geometrical shape. You have equations to solve, like, what is the length of the minor axis, what is the length of major axis, how much time does the planet take to revolve around it. So, like, it is, you can consider this to be a geometrical shape for that matter, right?
We can divide it into two circles with two sides. Like these two, like we can divide it like this. Because focus is the center of the circle, right?
Right, focus is the center of a circle. It can be divided into, let's say, like, the way that you are saying, I can draw here one circle from here, another circle from here, but, like, that will give some symmetrical shape. So this is, I mean, like, it is a different concept than circle, but, like, this is to explain a different type of diagram, okay, different type of, let's say, shape. This is known as ellipse. So the second law of Kepler, it says that every planet, right, traverses equal area in equal amount of time. How do we understand this thing? For this, like, let me draw this thing. Let's say, like, this one is area 1, okay, this one is area 2. area 1, area 2. Means from here to here, for traveling this much distance, okay, from traveling this much distance, let's say it has taken T1 from this point to this one. From here to here, it will again take T1, okay. And this area, okay, means the time taken to travel this distance, this area 1, okay, time taken to travel area 1 will be equal to time taken to travel area 2, it says. It means the planets will sweep equal area in equal amount of time when they are revolving around the sun. And in this process, what is happening? If the planet is away from the sun, in that case, it will be covering lesser distance. And if it is near the sun, it will be covering more distance in same amount of time. Are we seeing? The second law says the planet will be covering equal area in equal amount of time while revolving around their star, while revolving around the sun. So the time taken from here to travel will be equal to time taken from here to here. This area will also be equal. This area will be equal to this particular area, the shaded region, the area that we are talking about, this area will be equal to this area. But the thing is, like, you know, this distance is smaller than this distance. It simply means when the planet is near the sun, it travels at a faster speed as compared to when it is away from the sun, okay. And this distance from, let's say, this foci, this particular distance, this is known as perihelion, okay, it is known as perihelion. And this distance, I mean, like, the farthest point is known as aphelion, aphelion. This is known as aphelion, okay, perihelion and aphelion. The second law says every planet takes, let's say, you know, sweeps equal amount of area in equal time interval. This is the second law of Kepler. The third law, with this, we will move to the third law. It will be traveling faster.
Then it should take, the length should be less.
Length less, but area it sweeps is more. See, now here you have a confusion over here. Let's say this is the planet, it is moving from here to here, right? It travels more distance, but the area that it covers, area will be this much, right?
Regarding the speed of the planet, whether it will be faster near the sun or slower near the sun.
When it is near the sun, it will be traveling faster. When it is away from the sun, it will be traveling slower. Those planets that are near to the sun, they have, let's say, faster time. They travel faster. They take lesser time to complete one revolution around the sun. Those planets that are far away, they take, let's say, more time. Now, the third law, Kepler's law, Kepler's third law. This is just to brush up your basics related to the science and technology. The Kepler's third law says that the square of the time period, right? Square of the time period is proportional to cube of semi-major axis. Okay, it is proportional to cube of semi-major axis. So what is semi-major axis? So we have drawn, let's say this is F1, this is F2. From here, the distance is, let's say, like, you know, major axis, we discussed that major axis will be equal to 2a, right? So from here to here, this distance is a, and from here to here, this distance is again a. So it says the square of the time period of revolution of a planet is proportional to the cube of the semi-major axis of the planet. Okay, it is proportional to cube of semi-major axis of the planet. This is Kepler's third law of motion. So Kepler has given 3 laws of planetary motion that describes, right, the laws of motion of the planet, let's say, around its star, around its sun. Okay, so these are some of the basic things related to it. Now let us come to this thing, Earth Moon thing. Okay, Earth Moon.
Just a small law, right?
Mhm.
What is the significance of this? Like, these are in mathematical equations. So what is the practical significance of these laws?
What is the practical significance of these two laws? The first law you understood, practical significance, that talks about the path that a planet follows. First law. So I'll be quick in making you understand this. First law of Kepler's first law says the path that a planet follows while revolving around the sun. So that will be elliptical in nature. So it says like it will be following elliptical. Second thing says that like every planet equals sweeps equal amount of area in equal time interval from the foci where its star is located. Let's say this planet, like it has covered t1 time from here to here. Then it has covered, let's say it has taken t1 time from covering here to here. This area will be equal to this area. This signifies what it signifies. It signifies that like the planet that are located far away, they will be having more revolution time. Those planets that are near, they'll be having lesser revolution time, means like they'll be moving faster because this speed is inversely proportional to time. Na? Speed is inversely proportional to time. Speed is inversely proportional to time, we know. Like lesser the time, more will be the speed. More the time, lesser will be the speed. So this talks about this thing. Basically, like it talks about this area itself, that it sweeps equal amount of area. This helps in calculating, right? Means like how much area does it traverse in what amount of time, like that. The third law says that the square of the time period of revolution of a planet will be proportional to the cube of the semi-major axis. It talks about like what will be the length of the axis with reference to the time that it takes. So if we know the time period of revolution of a planet, that like in this, for example, for Earth we know it takes 365 days, 4 hours, like the let's consider 365 days to travel. So using this equation, right, if we put proportionality constant, we will get to know what is the length of semi-major axis. We will be knowing that like where is semi-major axis located. So that will help us in calculating other parameters of the ellipse of the path that it follows. Right. So with this, now let us come to Chandrayaan 3 mission, right? So Chandrayaan 3 mission, we are going to discuss in detail about it. So this Chandrayaan 3 mission was sent by Indian Space Research Organization, right? So this mission was sent by ISRO on 14th of July, okay, on 14th of July. And it has achieved one of its target on 23rd of August, yesterday, right, on 23rd of August. The target of doing a soft landing, okay, target of doing soft landing on the south pole of the moon, on the south pole of the moon. It has achieved this thing. So for this, we need to understand about what are the objectives of this Chandrayaan mission, how Chandrayaan mission is significant, right? So we are going to discuss all about it. So this, I mean, like, ISRO has sent the Chandrayaan mission. For that, like, we are going to, let's say, understand this particular thing, okay? So this Chandrayaan mission was sent through a vehicle, right? This vehicle is known as Launch Vehicle Mark III. What is the name of the vehicle, launch vehicle? It is known as Launch Vehicle Mark III, okay? Launch Vehicle Mark III is the heaviest launch vehicle so far that Indian Space Research Organization has, okay? So this is Launch Vehicle Mark III. It was launched on this particular date. The travel duration for the mission was 42 days, okay? So we have achieved 42 days. Then where it has landed, it has landed on lunar south pole, okay? It has landed on south pole of the moon. So that day I had drawn that, like, the moon, like, we have understood one concept which is known as what? Tidal locking. So the moon is tidally locked with Earth, right? So we have done this particular thing on the south pole. Okay, so landing was scheduled on 23rd August. So on 23rd of August it has landed, right? It has landed on the south pole of the moon. And since it has landed on the south pole of the moon, right? So we need to understand about, let's say, some components related to the mission. One of the and we are going to understand about the objectives of the mission also. It has three broad objectives as we discussed earlier. One of the objective is to demonstrate safe and soft landing on lunar surface. So we have demonstrated this. So India became the fourth country in the world that has landed on the surface of the moon. We have become fourth country. Like there was Soviet Union, then we have the United States of America and China. So these countries have landed, right? Have landed their spacecraft on the surface of the moon. So we became the fourth country in that respect. And to land any spacecraft on the south pole of the moon, India is the first country in that respect. Okay, no other country has so far landed on the south pole of the moon. Okay, so India has landed on the south pole of the moon. So in this regard, India is the first country, right? First country to land on south pole of the moon, to land on the south pole. Okay, on the south pole of the moon. Now, what is the second objective? The second objective is to demonstrate rover roving on the moon. So now this pro will demonstrate. So like, as part of this mission, they had three modules. One is propulsion module, then there was lander module. Inside the lander module, there is a rover. Lander has already landed, and from the lander, inside the lander, rover is going to come out, and that rover will rove, means like it's going to travel on the surface of the moon. So this is going to be the second objective of the mission, to demonstrate rover roving on the moon. The third objective is to conduct in situ scientific experiments. Okay, in situ means on the surface of the moon we are doing scientific experiments. It is going to do chemical analysis of the minerals that it finds, right? So it is going to help us understand whether there is presence of water ice on the surface of the moon. After this, right, so what is the mission life of the propulsion module? So propulsion module has already separated from the lander module. It has a mission life of 3 to 6 months. However, the lander that has landed on the surface of the moon, right, that lander has a mission life of 14 Earth days, which is equal to 1 lunar day. This 1 lunar day is also known as sidereal day. Okay, 1 sidereal day. Okay, 1 sidereal day means like this. It has a mission life of 1 moon day. 1 moon day means it has been made to land on the south pole of the moon over here in the early morning timing. With reference to the moon, the earth and moon sees the sun in a different time frame. So when it was evening time here on earth, it was very early morning time on the surface of the moon. So the thing is like, this particular part of the moon where we have done the landing of this Chandrayaan-3. So from there it has just, let's say it's it's early morning. So it will be 14 Earth days, which will be equal to 1 moon day, and during that time it's going to continuously receive sunlight. And on the rover we have installed many solar panels. That solar panel is going to get powered through the sunlight that is receiving, right? And using that power, it is going to conduct its scientific experiments. It is going to share the data with the, let's say with the orbiter of Chandrayaan-2. In Chandrayaan-2, we had sent lander, rover and orbiter. The orbiter of Chandrayaan-2 is still functional, and that orbiter is still, let's say being used by ISRO. So the thing is this, during this period of time, it is going to give us results. So over the period of next 14 days, we are going to get one or other, let's say output from Chandrayaan module. So ISRO is going to share it with all of us. And so what were the components of this particular mission? One of the component is propulsion module that helped the Chandrayaan, a thing to carry the lander along with it. So its main purpose was to carry the lander along with it, something like that propels, that helps something to travel like that. So lander module has already landed on the south pole of the moon. This is the image of the lander module. So it has, lander itself do not have let's say like wheels. It has something that will help it to make a soft landing. So it has already done the soft landing. And inside the lander module we have rover. Okay, what we have the rover module inside the lander itself. This is the weight of the propulsion module. Together they have a weight of around 2,900 I think, or 3,900 kilogram. Okay, so this is the weight of the, let's say, Chandrayaan thing. So having understood this, let us understand some other scientific things also. Then we are going to understand how it makes India, right, and a country, right, that has made a feat, which has achieved a milestone. So the thing is, like, for this particular mission, we have sent, right, we have sent a vehicle, space vehicle, launch vehicle, which is launch vehicle Mark III. Which launch vehicle we used? Launch vehicle Mark III. So this has been launched from Sriharikota. Okay, it has been launched from Sriharikota. It has taken off from Sriharikota. And initially, when we have launched this particular module, right? So after launching, it started, let's say, like, revolving around the Earth in a certain orbit. Then we have done some changes in its trajectory, that is known as maneuvering. So we have maneuvered its path. We have maneuvered the path of the mission for 5 times. What we have done orbit raising maneuver. It is known as orbit raising maneuver. So we have, like, raised its orbit 5 times, and after then, let's say, like, we have sent it to the moon. So initially we have raised the orbit, and after achieving certain orbit, then we have made it to, let's say, like, go to the moon. Once it has reached the, let's say, moon's gravitational influence, then, like, it was into this orbit initially. So once it has reached the moon, then we again have done maneuver, which is known as orbit lowering maneuver. What we have done? Orbit lowering maneuver, which means, like, we lowered its orbit for 5 times. Then we have made it to come to, let's say, 100 kilometer, this circular orbit. And from there, like, we have planned for soft landing. Okay, we have planned for soft landing. So it has done soft landing also. So integrated module phase means the phase through which, integrated phase was where the propulsion and lander module were going together. Okay, that was integrated phase. After then, like, we have separated the propulsion and lander module. Then the lander module was made to land on the surface of the moon. After this, we need to understand this particular thing, that, like, this lander module, like we have already discussed, it has carried what? It has carried the rover also. Then if we talk about this launch vehicle Mark III, LMV3, so it has different stages. The first stage is 2 strap-on rocket boosters. Okay, so means, like, these are the things, these are, let's say, engines. These engines help it to, let's say, lift off. So it had 2 strap-on rocket boosters. Then second stage had 2 Vikas engines. Okay, Vikas engines. Name of the engine is Vikas engine. Then third stage powered by a cryogenic engine. Cryogenic engine means that works at a very low temperature. Okay, it works at very low temperature. So that that's the thing. This is, I mean, like, related to the technicalities of this particular mission. So we have already discussed the orbits of this particular, moon mission. We have discussed about, like, how we have made it to change its orbit. Okay. It has many, let's say, technical things associated with it. One of the thing is, let's say, like, Sriharikota is located on the sea shore. It is nearby sea. Okay, sea. What happens if we are launching something? There is a probability of failure also during the launch time. If we launch it from a place where, like, we have human habitation, right? If it fails, it's going to, let's say, damage the human habitation. It's going to damage the structures. It's going to kill human beings. Okay, so that's why we generally, I mean, like, all space stations across the world, they prefer a location which is isolated, which is far away from the human habitation, right? So that, like, if any damage happens, that should not kill the human beings, because, like, there are international laws that says that, like, if your space vehicle, if your space objects is going to affect, let's say, any human being, then you will be made responsible. Okay, so we have discussed about outer space treaty. We have discussed about let's say, like, the moon agreement also, right? As part of those agreements, it is mentioned, right? A country which is spacefaring, if their space debris are affecting the structures of other country or human being, then that country will be made responsible, liable. So we are liable for the damages that our components make. So that's why we don't want to hurt the human being. So that's why Sriharikota is a very isolated place from the mainland, okay? And it is very much near to the sea. If let's say there is a damage, if something happens, right, in that case it is going to fall on the Indian Ocean, it's going to fall on Bay of Bengal, like that. So it's going to fall on water body. There we rarely have any human being, okay? And also we choose the timing in such a manner that like it meets multiple criteria. One of the thing is like it is able to reach to the specific orbit. Then other criteria is means like that timing should be suitable, right, for the object to reach the desired destination. So many things are there. So main thing that we consider is like, you know, the location should be far off. Second important criteria is that that particular place is located along the equator, okay? Let's consider this is Earth, and this line which divides the North Pole and South Pole or Northern Hemisphere, right? This is North Pole, this is South Pole, this is known as Northern Hemisphere, this is Southern Hemisphere. So the thing is, this Sriharikota which is there, it is very near to this particular thing, what? Equator. So when Earth is rotating, okay, what Earth is doing, it is rotating. So when Earth is rotating, we have the highest speed on the equator, okay, means like, you know, on the equator. So we have the highest speed like that. So it attains maximum thrust from here, okay. So that's also a reason, okay, to choose that location. So that's the thing. Now, so we have already discussed about these things, like, you know, it has taken off from the Sriharikota, rocket detached, right? Then Chandrayaan-3 orbits the Earth in phases until it enters the Moon's orbit, right? And from Moon's orbit, we have done orbit lowering maneuvers and all. So these things have already been explained to you, okay? So we have done many, like, you know, many kind of maneuvers on the path, during the path of this thing. Now, this is, let's say, yesterday's update from Moon mission, yesterday's update. So it has taken around 19 minutes to lower that particular lander from the, let's say, you know, atmosphere of the, atmosphere means like on the top of the moon to the surface of the moon. It has taken 19, let's say, minutes for this particular experiment to happen. So in this thing, they have mentioned like at what time what we have done. Initially, they have, let's say, like, you know, started doing the orbit lowering maneuver. So that that is known as rough, like, you know, rough braking phase. Okay, initially when we have done, so that is rough braking phase. That time, like, it was going down at a very faster speed. When, let's say, it was about to touch the surface of the Earth, we have, you know, made it to go it slow. So we have, you know, continuously slowed its like, you know, its trajectory, so that, like, you know, it can make soft landing, okay, easy landing on the surface of the moon. Okay, so it has captured a image also. Chandrayaan-3 has captured an image, and this is the image of the, like, image of the surface of the moon, right? So the European Space Agency has also helped us, right? European Space Agency, and also NASA has helped us related to some communication related to things related to Chandrayaan-3. Now let's discuss about how this mission, right, is going to help India, right? How India is going to get benefited. Okay, so India's achievement, we can say achievements, or how India is going to get benefited. For that, one thing is, like, you know, it has made India's technical progress, okay, progress. It has demonstrated India's capacity to be the first country that has done soft landing on the surface of the moon, okay. So it showcases India's technical prowess, and it's going to boost, what it's going to do, it's going to boost scientists, okay, scientists morale for conducting such experiments in the future, right? And also success of this particular mission, the government or the political, let's say like, political willingness to spend more in space exploration. Okay, so this political willingness will also go up. Okay, political willingness to spend more, right? To spend more on space activity will go up. Fourth thing is we'll be able to collaborate, right? What we are going to do, we are going to collaborate with other countries. We are going to collaborate with other countries in many other space exploration related activities. Okay, and what are the projects in which we are going to collaborate? I'm going to discuss about those projects also, right? So it is going to help in these areas. Now, what are the next missions of ISRO? If I talk about like, what will be the next missions of ISRO? Okay, next or upcoming ISRO mission. Upcoming missions of Indian Space Research Organization. We are going to discuss about this. So one of the mission is Aditya L1 mission. Okay, Aditya L1 mission. What is Aditya L1 mission? So through Aditya L1 mission, what we are going to do, we are going to study the sun's corona. What we are going to do, we are going to study sun's corona. How? Through X-ray polarimeter. Okay, X-ray polarimeter. Okay, so now what is L1, right? We need to understand L1. L1 is known as Lagrange. Okay, Lagrange point 1. So what are Lagrange points? This is important. Basically, Lagrange points are those points in the space where a satellite or a spacecraft experiences almost zero gravity, right? For example, let's say like, this is sun. Let me draw this. This is focus 2. This is focus 1, right? And let's say this is Earth. Here we have Earth. It is important for you to understand this. Okay, so this showcases Earth. This point showcases sun. Let's say this showcases the moon. Between Earth and sun, there are points. Let's say like, this is a point. So I'll be taking another this. Okay, there are points. Let's say this is a point. This is known as L1 point. So at this point, right, at this point, this is known as Lagrange point 1. At this point, if we send a spacecraft, right, if we send a spacecraft, this spacecraft or satellite. Let's say we are sending a satellite. This spacecraft or satellite will experience, right? Will experience what? Zero gravity. Okay, it's going to experience zero gravity or very less gravity. Okay, it's going to experience very less gravity. Between any planet and its sun, there exist 5 Lagrange points. Okay, there exist how many Lagrange points? 5 Lagrange points. So these are, so I'm going to draw these Lagrange points one by one. Let's say this is Lagrange point 2, that was Lagrange point 1. Then we have Lagrange point 3, which will be on the opposite side of the planet, right? Then there will be Lagrange point 4 and 5. This is known as L4 and L5. Okay, L4 and L5. So at these places, what happens, like in these Lagrange points, whether in Lagrange point 1, Lagrange point 2, 3, 4, 5, if we place any spacecraft, any object, it is going to experience very nil, almost zero gravity. Okay, so these Lagrange points are important. However, like Lagrange point 1 is very close to Earth, it is very near to Earth. Lagrange point 2 is Earth. However, Lagrange point 2 is more stable. Okay, this will be more stable as compared to Lagrange point 1. Okay, it is more stable. This is stable, this will be stable, this is less stable relatively, and these are also stable. However, these points are very far away. Okay, these points are very far away. So this Aditya L1 mission will be sent, I mean, like we are going to send a spacecraft, right, which is going to study the sun's this thing, what corona, it's going to study this thing. So that's why we have chosen Aditya L1 point for this particular thing. So here this is upcoming mission. Okay, this is upcoming mission of ISRO. So this is also an important thing. Apart from this, like like when we talk about international collaboration, so India has signed international collaboration agreements with Japan. Okay, so Japan and India, they are together going to send another mission, okay, which is known as lunar mission. It is in short known as LUPEX. Okay, LUPEX. LUPEX stands for lunar polar. Okay, it stands for lunar polar exploration mission. Okay, it is lunar polar exploration mission. Lunar polar exploration mission. Okay, so in lunar polar exploration mission, basically like Japan wants to send, okay, this is primarily the moon mission of Japan. Japan wants to send, let's say, like any spacecraft on moon. It's going to, let's say, make a landing on the surface of the moon. For that purpose, this Japan, I mean, like Japan is going to take help of India, right? Japan is going to take help of India for which components? It's going to take help of India, for Chandrayaan 2 and Chandrayaan 3. Okay, and Chandrayaan 3, what? Like we have sent multiple modules, for example, lander module, rover module, and orbiter module. So they are going to take these modules for their benefit. Okay, so one is, let's say, orbiter module, orbiter, lander, and rover module. Okay, rover modules that we have used like for Chandrayaan mission. So they will be taking help from ISRO. So this talks about, like, let's say, India's growing power, growing, let's say, influence in the space sector. Okay, so this is lunar polar exploration mission. Okay, apart from this, there is another kind of mission that is working, right? So this mission, like if you want to note it down, just note it down quickly. Apart from this, there is another space program that is going to happen. This is known as International Research, okay, International Lunar Research Station Program. Lunar Research Station Program. Station Program. It is not totally of ISRO. This is an international program where China has, let's say, participated. I guess USA has also participated. So this success of Chandrayaan 3, okay, this success of Chandrayaan 3 will help ISRO to be part of this particular program also, okay, and India will be consulted for it. So it showcases India's growing, let's say, space influence, right, space diplomacy in this thing. Okay, so write down about this program. Apart from this, we are going to discuss an important, let's say, international collaborative project, and this is known as Artemis Accords. Okay, so what is this? We are going to discuss about an accord which is known as Artemis Accords. So what are Artemis Accords? Artemis Accords is, first of all, it is led by United States of America. So it's an international project, okay, international project, and it's a lunar project, okay, international lunar project. Now we need to understand this Artemis Accords has 3 parts, okay, it has 3 parts, okay, 3 parts of this Artemis Accords. What are those 3 parts? Number 1 is known as Artemis Accords 1, Artemis Accords 1. Second is known as Artemis Accords 2, Artemis Accords 2. Third is Artemis Accords 3, okay, Artemis Accords 3. What is the difference between all the 3? The Artemis Accord 1, what it wants to do? It wants to send, right, it wants to send the, let's say, lunar mission, which is going to do a landing on the surface of the moon, soft landing, okay. So that India has already achieved, means like through Chandrayaan mission, we have already achieved something related to Artemis Accords. So Artemis Accords is led by USA. India has signed this particular Artemis Accord, and Artemis Accords are non-binding, okay, they are non-legally binding, okay, non-legally binding instruments. In agreement, non-legally binding agreement for the country who are party to it, okay. So this is the thing. So one of the feat that it wants to achieve, that India has already achieved, right? The second feat is, means like, you know, they want to do lunar flyway. What? Lunar, this is known as flyway. What is lunar flyway? Means we are going to send human beings from Earth, let's say this is Earth, this is moon. We are going to send human beings through a spacecraft, and this spacecraft, let's say, will go to moon, but it's not going to do a landing on the surface of the moon. Means like, you know, let's say we are going to send it to such an orbit which will be very near to the moon. However, we are going to bring back the human being to the Earth. Means it is going to just fly nearby moon, and it is going to come back. So like, you know, that will be technically checking whether like we'll be able to land or not. Okay, so we want to send human being, you know, near the moon, but we will be just flying past by it. We will just pass through it. We will not land on it. Then Artemis Accords 3 talks about sending the next human beings on the surface of the moon. Under Artemis 3, we will be sending, I mean like USA along with other partner countries, they will be sending human beings who are going to land on the surface of the moon, and they are going to come back also from there. Like that, okay. So these accords have been signed by India. It has been signed by India, and this talks about like India's growing prominence also, right? USA is consulting India, and since India became the first country to have a soft landing on the south pole of the moon, so that's also an important thing that India has done. Apart from this, like if we compare, right, if we compare Chandrayaan 1, Chandrayaan 2 and Chandrayaan 3, right? So let us quickly do a comparison between Chandrayaan 1 Chandrayaan 2 and Chandrayaan 3 mission. Okay, if we do a quick comparison of these 3 missions that we have sent, all these Chandrayaan missions have been sent by Indian Space Research Organization. ISRO has sent Chandrayaan 1 mission in the year of 2008. And if I talk about this Chandrayaan 2 mission, it was sent by ISRO in 2019. Chandrayaan 3 mission, if I talk about this thing, it was sent by ISRO in 2023. Right? Chandrayaan 1 mission, like if I talk about the objectives of Chandrayaan 3 mission, Chandrayaan 1 mission, so it had many objectives. One of the objective is to let's say like, you know, send a rover. Okay, so we not rover, this is orbiter. So it will be having orbiter which is going to study the moon, right? You know, also this mission Chandrayaan 1 did not have any landing plan. Okay, so we just wanted to send something on the moon which is going to, let's say like, you know, orbit around the moon, and it's going to give us information. However, soon after, right, if I talk about achievements of this mission, so what we have done, like we have started receiving the information from here, and it has given us information, right? It has given us information that there is possibility of water ice on the surface of the moon, right? But after 1 year, like, we stopped receiving signals, okay? Signals stopped. We stopped receiving signals, okay? Signals stopped coming from here. So that was not a failure, but like, it had a limited lifespan, limited span of Chandrayaan-1 mission. So the thing is, like, this signal stopped coming to us in 2009, okay, in August 2009. Then ISRO has sent Chandrayaan-2 mission, right? Chandrayaan-2 mission had objectives similar to Chandrayaan-3. Okay, one of the objective is, like, it had multiple components. It had an orbiter, right? It had a lander. It had a rover, okay, similar to Chandrayaan-3. The orbiter went, okay, and after then separation happened. However, the lander and rover, they were together. So just 2.1 kilometer, like, above the surface of the sun, we stopped receiving signal. We lost control on it, and it had crash landed. What it has done, it has crash landed on the surface of the moon. It has landed definitely, but it has crash landed. So after then, like, we have lost contact with it, okay? Orbiter of Chandrayaan-2 is still functional, okay? It is still functional. So which is giving us data. Then Chandrayaan-3, its objectives, like, it had, let's say, like, objective means, like, I have discussed about components here. It had 3 objectives. One of the objective is soft landing, okay? Soft landing on the south pole of the moon, right? On south pole of the moon. So did we achieve this thing? This objective is achieved, first objective. Second objective, we want the rover, right, to rove around the surface of the moon, right? Rover to rove around the surface of the moon. So this is, like, we are still going to receive data related to it. Third thing is, this rover is going to do in situ, right? It is going to do in situ chemical analysis, okay? Chemical analysis of minerals, right? Of minerals on the surface of the moon. So this is still, let's say, like, on the ongoing stage. We are still waiting for it to happen, right? So this is the thing. So these are the, let's say, like, 3 different Chandrayaan missions: Chandrayaan-1, Chandrayaan-2, Chandrayaan-3. And are there other countries also that have done similar missions? There are many countries. Israel has also sent a Chandrayaan mission, but that was not done by any government space agency of Israel. So it was done by a private space agency. That mission is known as Beresheet mission of Israel, okay? And what they have done is, they have sent, like, the Hebrew version of Bible, their own, like, thing there, okay? So they have done. China's mission is known as Chang's mission. So they have landed on the surface of the moon. Then if I talk about Russia's mission, they are known as Luna mission. The USA has many different missions. One of the mission is known as Apollo mission of USA. Then Lunar Reconnaissance Program it has. And apart from this, they have another mission, okay? So USA has so far sent 3 different moon missions, and they have been successful also so far. And ISRO has assisted India in this particular mission also for signals that we receive, okay? So these are all things related to the Chandrayaan mission. So any question for me? See, now we need to understand. So you have asked about what is X-ray polarimeter. X-ray, what is X-ray polarimeter satellite? So basically, like, this is also one of the upcoming program of ISRO, right? So now we need to understand these things. First of all, we need to understand what are X-rays, okay? X-rays are part of electromagnetic radiation, okay? They are part of electromagnetic spectrum, okay? Electromagnetic X-ray is a part of electromagnetic spectrum. So electromagnetic spectrum has all sort of signals, from visible range to ultraviolet range to to let's say X-rays. Then we have gamma rays, beta rays and all. So these X-rays has certain frequencies. Okay, they have certain frequencies and they have certain wavelengths. Okay, they have certain wavelengths. So these, why do we do X-ray signals are important? Because X-ray signals help us in doing certain scientific experiments. For example, in human beings also we do X-ray. That X-ray goes through, right? It goes through our skin also. It helps us to identify the bones, whether there is any fracture on bones and all. So these X-rays are rays of the spectrum. So we have electromagnetic spectrum, big spectrum, and a small part of this electromagnetic spectrum is of X-rays. Okay, it is of X-rays. Now let us understand what is polarimeter. Okay, polarimeter means, let's say if I talk about light rays, you might have heard about that, we have light. We all understand what is light. The light that we can see, it is known as white light. Okay, the light we see, it is part of white light. This white light has certain components which is known as VIBGYOR. VIBGYOR means it has various color components in it, which is known as violet, indigo, blue, blue, green, yellow, orange, red. Okay, so inside the white light we have different color of light inside it, right? So that is white light. While studying in school, you might have understood about ray theory of light. Okay, ray theory of light means light has, let's say, multiple natures in it. One is known as ray theory, other is known as wave theory. Then light also showcases duality, which is wave matter duality. Okay, so initially, during your 10th standard and all, you might have understood, let's say, there is, if there is a mirror. Okay, what is this? There is a mirror. So what is the property of mirror? Property of mirror is it will reflect anything, any light that comes on it. Okay, it does have a property of reflecting. Okay, it does reflect. So the mirror concept is explained, mirror or lens related thing concept is explained using ray theory of light, that says that the light travels in a single direction, right, in a straight line with a speed of 3 × 10⁸ meter per second. So that talks about the ray theory of light. However, if I talk about wave theory of light, so we have let's say a principle, wave theory principle. So that wave theory says that a small let's say wave packet of light, what it generates secondary wavelets. Okay, it generates secondary wavelets, and these secondary wavelets travel across all directions. Okay, then these secondary wavelets are source for the next wavelets. Okay, they are source for the next wavelets, like that. So this wave theory of light says that the light travels in all directions from one specific source. If let's say light is here, so it is going to travel in all directions. So it says wave theory of light. So according to the wave theory of light, light does have many components, and to study the properties of light, to study how let's say polarization happens in light. Polarization means changes in the direction and changes in the wavelength, right? How the polarization happens in light. So for that, we do have something components which are known as polarimeter. Okay, so using polarimeter, what we want to do, we want to study, right? We want to study the, let's say, nature of light, how polarization happens on light. And this polarimeter is going to help us understand the lights that are emitted from the sun. ठीक है, सन से जो लाइट आता है उसमें पोलराइजेशन कैसे होता है. ठीक है, सो वी डू हैव मल्टीपल प्रॉपर्टीज ऑफ लाइट, जैसे यू माइट हैव हर्ड अबाउट डिफ्रैक्शन ऑफ लाइट, स्कैटरिंग ऑफ लाइट. ठीक है, देन डिफ्रैक्शन ऑफ लाइट, रिफ्लेक्शन ऑफ लाइट, ऐसे पोलराइजेशन ऑफ लाइट भी होता है. दैट्स पोलराइजेशन ऑफ लाइट दैट हेल्प्स यू टू अंडरस्टैंड कि लाइट का जो है ना, मतलब हाउ, let's say how different colors are generated maybe. ठीक है, polarization को study करने के लिए we use polarimeter. So this polarimeter is going to understand the polarization of light using X-ray waves. Okay, X-ray waves. X-ray waves are part of electromagnetic radiation. is it understood? We can go into deep about it, but the thing is like, that will be very technical. Yes. So any other question from the people who are attending online or offline? No? So this is, I think this is taught by Huygens principle of Huygens. Okay, Huygens principle. So that talks about कि light जो है ना are source for secondary wavelets. ठीक है. So light के दो property होता है. एक तो होता है ray theory, and other is wave theory. Then like matter duality also there. Sometimes light acts as a matter, sometimes it acts as a particle as well. And if you understand the, let's say, light wave duality, then you will be studying about quantum physics. When we study quantum physics, then we learn about various things related to light. ठीक है, quantum physics में we understand कि photons क्या होते हैं. You might have heard about photons. Photons are energy packets, right? So they are energy packets. जो light that, let's say, if we are standing here, sunlight हमारे ऊपर पड़ती है, so we get क्या गर्मी लगता है, ठीक है, मतलब like sunlight has some energy in it. ठीक है, so मतलब like it acts as, like let's say lights also act as particles. They are known as मतलब like photon energy packets. तो इसमें मतलब like there are this is known as a standard model of physics where we study various components inside the light also. कि मतलब like बहुत सारे वो चीज़ें. We understand about fermions, we understand about electrons, we understand about muons. ठीक है, मतलब inside the atom, that like higher level of study we do. Okay, so these things are connected with one another. So any questions so far on Chandrayaan? Online people? Okay, all right. So that will be all from my side for today. Thank you so much everyone for attending today's session. I hope this might have been uploaded, the editorial discussion topic. I have not yet reviewed the topic. I need to review it. If anything is there, so I will get it edited also, then we will upload. Okay. So thank you so much.